We're here with the Storm Prediction Center's Russell Schneider, Director, and Steve Weiss, Chief of Support, two members of a team of 8 with NOAA's Hazardous Weather Testbed. This team, which includes Jack Kain, Mike Coniglio, Greg Carbin, David Bright, Jason Levit, and Jay Liang, has received the 2012 Kenneth C. Spengler Award for bringing the government, academic, and private sectors together in a visionary, proactive, and exemplary manner to deal with the challenges posed by hazardous weather. Congratulations.
Thank you.
Russ, can you explain a little about the Hazardous Weather Testbed?
Yeah, in many ways, some would see it as a room, but it's much more than a room. It's a collaborative environment that we've constructed over many years, really. Contributions from a lot of people, including certainly those of us in the awards, but some of those that weren't mentioned in the award. It's a collection of folks that have a common vision towards translating research into operations and into benefits for society. And that collaboration has grown and begun to encompass more and more facets of the problem of hazardous weather, from the forecast side over to the warning side. Includes the new geostationary satellite platform from GOES-R, and it includes a wide swath of the community.
Okay, now there are 2 programs involved in the testbed, the Experimental Forecast Program and the Experimental Warning Program. And Steve, what's the distinction between the 2?
It's the different time scales of the phenomena that we are attempting to either warn for or forecast for. The Experimental Warning Program focuses in the first 1 to 2 hours in testing new tools such as phased array radar, dual pole radars, a variety of multi-sensor approaches from multiple radars in order to improve the warnings of severe storms within the next hour or so. And a real key in what they are doing is trying to stretch the warning lead time in a concept called warn on forecast out beyond the current 30 to 45 minute standard lead times. Now, where we pick up on the experimental forecast side is in a slightly longer time frame, anywhere from 2 to 3 hours out to 2 to 3 days in predicting the occurrence of severe weather. Much of our focus has been on the use of cutting-edge advanced numerical modeling systems, high-resolution models that we call convection allowing, that can explicitly represent some processes of thunderstorms within the model. We've been experimenting with those over the last several years and really testing the ability of these modeling systems to provide us with useful guidance over the next day or 2 in forecasting.
I see, okay. So then what is NOAA's leadership role in coordinating the different facets of academic, government, and private sector collaboration?
I think the real key from a NOAA perspective is, and particularly the Storm Prediction Center, is we bring the focus, the lens of operations, national severe weather forecast operations, to the forecast component of the experiment, and the drawing of the science towards a service objective, which we embody in our 24/7 operations at Storm Prediction Center, is a real key as part of the leadership. Certainly our facilities, our data flow, are a key part of the infrastructure to sustain the collaborative environment. The intellectual energy is also important, but that provides a steady platform in which we can engage the community. We have key partners within the universities, such as the University of Oklahoma locally, but from throughout the United States, also partnerships with folks throughout the world. The private sector, as the award mentioned, and really we provide that focus, the lens to focus the activities, and also the core infrastructure.
I see. Well, I'm wondering, Steve, can you give a few examples of the research advances that your team has moved into operations?
Certainly. As Russ has mentioned, we've partnered with probably the major numerical modeling organizations within the country, not just the Center for Analysis and Prediction of Storms at OU, but NSSL, Global Systems Division of ESRL, part of NOAA, Environmental Modeling Center, part of NCEP, and NCAR as well. And we are working with all of these groups to try and improve the high-resolution modeling of hazardous weather events such as severe thunderstorms and tornadoes. And over the last 3 to 4 years, A number of these models have become operational at the Environmental Modeling Center within some of the model runs that they make, and some of the models that are still considered somewhat experimental. They're actually run every day in a reliable manner from GSD as well as NSSL in order to provide additional information to forecasters, and these are utilized by forecasters not just at the Storm Prediction Center, but across the National Weather Service.
What outstanding hazardous weather challenges is the testbed currently moving through research into operations?
Some of the big challenges that we're dealing with now are related to predictability of small-scale events. There are limits to predictability, and a single model may not be able to specifically predict what's going to happen. So what we are focusing on over the last few years has been the development of high-resolution ensemble prediction systems, where you have a number of model runs that may have small differences in either initial conditions or model physics associated with these different members, producing forecasts all valid at the same times. And through this, we can extract information about particular types of storms, storm hazards, and we're learning how to extract information in a probabilistic way that will give us measures of uncertainty as well. So this is really the frontier where we're working on now, is how to develop better high-resolution ensemble systems so that we can incorporate a measure of uncertainty or predictability into the forecast process.
I see. Now, as you moved along through this process, what, if anything, might you like to do differently?
Yeah, I think one of the things that we learned just from this recent tornado season with over 550 fatalities nationwide, I mean, this is the largest death toll since before we had severe weather warning systems and severe weather forecasts. The forecasts and warnings were excellent this year, but many people died. So there's a real focus on improving the last mile, and in order of communicating the hazards to the public, and in order to do this more effectively, there's a growing consensus that we need to integrate the social sciences and the physical sciences more completely. Not just for the end of the process, but fully within the process. So we'll be working to integrate the social sciences into the hazardous weather test bed more fully. They've already participated, but make that a more robust interaction. And hopefully that'll prove a more comprehensive from the research all the way into operations and the communications piece.
Russ, what would you say to colleagues in both research and operations asking about the merit of such an achievement as this award?
Yeah, I think this speaks to not just the NOAA leadership, but each of the folks that have participated with us in this endeavor. It was really a coalition, and we were looking for individuals, researchers that were committed towards transitioning their ideas into operations and into value for society. And we found those type of collaborators throughout our community, both academia and private sector and throughout. I think the key in the development of the activity was looking for win-wins, meeting people's needs. We didn't have large resources in order to create this. We really looked towards people who had a commitment towards the ideals. It was really a larger, higher purpose that we were aiming for. And we brought people together about that higher purpose. We looked for visionary topics that would push us forward in a dramatic fashion that would be of interest to both the research and the operational community. And I really think it was an excellent example, not of what we did, but of what the community can do when you pull together around something that's a very important ideal and make it a reality.
Well, thank you for taking the time to speak with us, and congratulations again.
Thank you.
Thank you very much.